Welcome to the Deep Dive. Today, we're pulling back the curtain on something we all see, something that stands as a silent sentinel in our homes and workplaces, but maybe you don't truly understand. The portable fire extinguisher.
Right.
You know the ones, those often red, sometimes silver cylinders hanging on a wall, just, well, waiting for that one moment of crisis.
That silent guardian.
Exactly. But what actually goes into making sure that, that unassuming device is genuinely ready when you need it most?
Yeah, that's the key question.
And perhaps more importantly, are you, the listener, ready to use it effectively and safely? We've received a fascinating stack of detailed sources for this deep dive. Excerpts from NFPA 10, the Standard for Portable Fire Extinguishers 2022 edition, along with insights into its rich history and comprehensive annexes. It's quite a bit to unpack.
Indeed it is. And this standard NFPA 10, it's far more than just a rule book. It's really a living document, a cornerstone of fire safety meticulously developed through a rigorous collaborative consensus process.
Consensus process. Okay.
Yeah, it truly underscores that fire safety isn't merely about, possessing an extinguisher. It's about ensuring you have the right extinguisher, installed precisely, maintained diligently, and crucially, knowing exactly how to deploy it effectively and safely in those critical first moments.
Right. So our mission today is to distill this incredibly comprehensive standard into essential, actionable knowledge. Think of it as a shortcut to being genuinely well-informed.
A practical guide.
Exactly. Packed with surprising facts and practical takeaways that could genuinely impact your safety, maybe even save a life, we'll journey from the fascinating origins of these devices to how they're rigorously tested, what makes them unexpectedly obsolete, that's a big one,
Oh, yeah.
and even the vital differences for home use. Okay, let's unpack this and discover the hidden layers of safety.
The foundation of fire safety, NFPA 10, explained.
Okay, so before we plunge into the specifics of extinguishers themselves, let's maybe establish the bedrock of this entire system.
Yeah.
What exactly is NFPA, and what's the fundamental nature of a standard like NFPA 10? Because understanding the source, well, it gives us so much more context, right?
That's a great starting point. Yeah. The National Fire Protection Association, or NFPA, it's a global nonprofit organization, and its singular vital mission is basically to eliminate death, injury, property, and economic loss due to fire, electrical, and related hazards.
It's a big mission.
It's huge. And their standards, like this 2022 edition of NFPA 10, they aren't just arbitrary rules dreamt up in an office somewhere. They are developed through an incredibly rigorous and deliberate consensus process.
Okay, consensus. What does that actually involve?
Well, it's ultimately approved by the American National Standards Institute, or ANSI, but the key is it isn't a top-down mandate. It's a truly collaborative effort. Imagine bringing together, a diverse group of hundreds of volunteers.
Hundreds, wow.
Yeah. Bona fide experts from all corners of the fire safety world. Fire service professionals, manufacturers, scientists, installers, even end users, They all come to the table, often with varied viewpoints and interests, to hash out the best possible practices.
So they argue a bit.
Oh, I'm sure there's vigorous debate. But the goal is always to achieve consensus on fire and other safety issues, to develop the safest, most effective, and most practical solutions through shared expertise and real-world experience.
That consensus process sounds incredibly complex, but it does highlight just how much expertise goes into keeping us safe. But what's fascinating here, and something I think many people might not realize, is what NFPA doesn't do, right? This seems like a critical distinction.
Absolutely. Yeah, this is a point of clarity that often surprises people. NFPA itself doesn't independently test, evaluate, or verify the accuracy of information within the standards.
They don't test their own standards.
Not directly, no. They don't guarantee or warrant the completeness of any published information either. And they certainly don't render professional services like, say, certifying installations or inspecting buildings.
Okay.
What they provide is the definitive blueprint, the consensus-driven best practices. This means that users, like, building owners, facility managers, even homeowners, must rely on their own independent judgment or seek professional advice when interpreting and applying these standards.
Right.
The NFPA essentially creates the meticulously crafted codebook, as you put it earlier, but the responsibility for its correct application and enforcement rests squarely with the end user or the enforcing authority. They're setting the bar, not policing every single step to reach it.
So it's less about them being the police and more about them building the code book. That framework, that meticulously crafted guide, then relies on proper application. And that falls to the user, or more formally, the authority having jurisdiction, the AHJ. What exactly is an AHJ in this context? Because that term feels, well, pretty broad.
It is broad, but incredibly important, yeah. AHJ stands for Authority Having Jurisdiction, and it refers to the organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, and installation, or a procedure.
So it could be different people in different places.
Exactly. Depending on the situation, the AHJ could be a local fire chief, maybe a state fire marshal, a city building official, or even a labor or health department official.
Okay.
For insurance purposes, it might be an insurance inspection department, or in the case of federal properties, it could be a commanding officer or a departmental official. And in many circumstances, it's actually the property owner or their designated agent who takes on that role.
The owner themselves.
Sometimes, yes. This highlights that these NFPA standards aren't just good ideas. They often become legally mandated requirements when adopted by one of these diverse AHJs. It's the mechanism that translates those best practices into law in many cases.
Right, the enforcement piece. Now, standards are living documents, always adapting to new technologies, new hazards, new understandings of human behavior. I'm curious, looking at NFPA 10's long history, it goes way back.
Oh, yeah, way back.
What's one of the most maybe surprising ways it's had to adapt to keep us safe? What was a real game changer in its evolution?
That's a great question because the evolution of NFPA 10 truly mirrors advancements in technology and our understanding of fire dynamics. Its origins trace all the way back to 1918 and 1919.
Wow, over a century.
Yeah, with the earliest official standard adopted in 1921. It actually underwent revisions almost annually for decades in the mid-20th century, which is quite a testament to the ongoing commitment to improvement.
Almost every year.
For a long stretch, yeah. But if I had to pick a real game changer, I think the 1984 edition stands out. It was a true turning point where NFPA really focused on the user experience in a high-stress emergency.
User experience. How so? Were people just, I don't know, freezing up or getting confused by the instructions back then?
Precisely. That's exactly what they found. They conducted these things called novice fire tests, essentially, putting regular people, not trained firefighters, in simulated emergency situations.
Good.
And what they found was truly eye-opening. Users struggled significantly with text-only instructions, and even simple tasks like correctly pulling the pin became difficult under pressure.
I can imagine. Your mind goes blank.
Exactly. So this direct feedback from real-world high-stress scenarios led directly to the now ubiquitous pictographic operating instructions and new code symbols. That easily recognizable pull, aim, squeeze, sweep concept.
Pass right.
Pass, yeah. Visually communicated, it began to solidify in the standards then. It wasn't just about the extinguisher itself. It was about how a panicked human being actually uses it in those critical moments. That shift to user-friendliness in high-stress situations was, I think, a massive leap forward in making portable extinguishers truly effective for everyone.
That makes so much sense, adapting to human factors.
Absolutely. And the evolution continued, In 1998, information on residential fire extinguishing equipment was incorporated as an annex, making it a more integral part of the main standard, acknowledging the unique needs of homeowners.
So bringing it home, literally.
Right. Then the 2010 edition clarified terms and emphasized the need to remove obsolete extinguishers. We'll definitely get into that. By 2013, the standard addressed Class D extinguishing agents for combustible metals more comprehensively, and it accounted for the ongoing phase-out of halon extinguishers due to environmental concerns.
The ozone layer issue.
Exactly. It even expanded halocarbon definitions and updated travel distances for specific fire hazards, showing a more nuanced approach to placement. And more recently, the 2018 edition brought clarifications on electronic monitoring, expanded fire classification markings to include Class AC and Class AK, and refined annexes. It's truly a continuous journey of improvement, driven by real-world needs, testing, and a desire to make fire safety as effective and intuitive as humanly possible.
That deep dive into the language of the standard really shows us how precise these documents are. And that precision is absolutely vital when we start talking about the very different types of fires we might encounter, isn't it? To properly navigate such a detailed technical document, it seems clear we need to speak its language. What are some fundamental terms we absolutely need to know to properly understand NFPA 10, almost like a vocabulary lesson for safety?
Absolutely. Understanding the specific terminology is truly crucial because common words can have very precise, even legal meanings in a technical standard like NFPA 10. A few distinctions are critical to this deep dive, starting with the verbs shall versus should.
Okay, that sounds important.
It's fundamental.
Yeah.
Shall indicates a mandatory requirement, something you must do. No exceptions, no flexibility. If you see shall, it's non-negotiable for compliance.
Got it. Must do.
Should, on the other hand, is a recommendation or an advised action. It's strongly suggested as the best practice, but not strictly required. Missing this distinction can lead to compliance issues, or more importantly, significant safety gaps.
Okay. Shall is must, should is advised. What else?
Then we have terms related to product verification, which are often confused in everyday conversation. Approved, labeled, and listed.
Yeah, I think I use those interchangeably.
Lots of people do. But in NFPA, they have specific, distinct meanings. Approved simply means acceptable to the authority, having jurisdiction, the AHJ we just discussed. So what's approved might vary slightly by jurisdiction.
Okay, depends on the local authority.
Right. Labeled means that equipment or materials bear an identifying mark from an organization concerned with product evaluation. Think like Underwriters Laboratories, UL or ULC standards in Canada.
A little sticker.
Exactly. That mark indicates compliance with appropriate standards or performance in a specified manner, and that organization also maintains periodic inspection of the product's production. It's a stamp of quality and compliance, basically.
Right, and listed.
Listed means that equipment, materials, or services are included in a list published by such an organization, confirming it meets designated standards or has been tested and found suitable for a specified purpose. So while all three speak to credibility, approved is AHJ specific, labeled is about that identifying mark and ongoing production inspection, and listed is about inclusion in a recognized directory, all to verify credibility and compliance with essential safety standards.
Okay, approved, labeled, listed. Got it. What about the extinguisher itself?
Moving on to the equipment. A portable fire extinguisher is simply defined as a device, carried or on wheels and operated by hand, containing an extinguishing agent that can be expelled under pressure to suppress or extinguish fire. Pretty straightforward.
Simple enough.
Now, another critical distinction, especially for maintenance practices, is between rechargeable, refillable fire extinguishers and non-rechargeable, non-refillable fire extinguishers.
Okay, like disposable versus reusable.
Kind of, yeah. Rechargeable units are designed to undergo complete maintenance. That means internal inspection of the pressure vessel, replacement of substandard parts and seals, and hydrostatic testing. They're typically marked recharge immediately after any use.
Right.
Non-rechargeable ones are designed for a single use and are usually marked discharge and dispose of after any use or something similar. This is key because how you handle an extinguisher after any use varies dramatically based on this label. Don't try to recharge a non-rechargeable one.
Good tip. Don't do that.
Definitely don't. Finally, let's distinguish between extinguisher inspection and extinguisher maintenance. People mix these up too.
Inspection versus maintenance.
Okay. An inspection is a relatively quick visual check. Is the extinguisher in its designated place? Has it been tampered with or used? Does it show obvious physical damage that would prevent it from working? It's like a quick health check.
Something you could do yourself.
Yes, potentially. We'll get into who can do it. Maintenance, on the other hand, is a far more thorough professional examination. Its goal is to provide maximum assurance that the extinguisher will operate effectively and safely when needed.
Okay.
This includes determining if physical damage or condition might prevent its operation, if any repair or replacement is necessary, and if hydrostatic testing or internal maintenance is required. This distinction is crucial for who can perform the task, how often, and the level of expertise required. One is a routine visual scan. The other is a deep professional tune-up.
The firefighting toolkit classes, agents, and obsolete models.
Okay, now that we have the foundational language down, all those precise definitions like shall and should, listed, labeled, let's talk about the actual fires we're trying to fight. We can't pick the right tool if we don't know the job, right?
Exactly.
The standard clearly defines different fire classes. It sounds like this is truly the first, most fundamental step in effective firefighting.
That's right. And this is truly the first, most fundamental step in selecting the correct extinguisher. You wouldn't use a hammer to drive a screw, would you?
Hopefully not.
Right. Similarly, you wouldn't use water on a grease fire. These classifications explain why, ensuring you choose the right agent for the right fuel source.
Okay, so break down these classes for us. A, B, C, what do they mean?
Let's break them down because each one requires a specific approach. First up, Class A fires. These are your most common fires involving ordinary combustible materials. Think about wood, cloth, paper, rubber, and many plastics. These are the fires that typically leave an ash behind.
So, like your typical office trash can fire or burning furniture.
Exactly. Your overflowing wastebasket, burning furniture, a stack of cardboard boxes, that's a Class A. Next, Class B fires. This class is for fires involving flammable liquids, combustible liquids, and flammable gases. We're talking about gasoline, oils, solvents, lacquers, alcohol, anything that burns as a liquid or gas.
Okay, things that pour or flow.
Right. These are often fast-spreading, can produce intense heat, and can be especially dangerous due to their volatility. Then we have Class C fires. This category is specifically for fires involving energized electrical equipment.
Energized, that's the key word.
That's the key word. The energized part is absolutely critical. If you manage to de-energize the equipment, say, by pulling the plug or shutting off the power at the breaker, the fire then reverts to being a Class A or B fire, depending on what material is actually burning.
Oh, okay.
The C rating indicates that the extinguishing agent itself is non-conductive, which is crucial for protecting the user from electrical shock. You don't want to conduct electricity back to yourself.
Definitely not. Okay, A, B, C. What else is there?
There's Class D fires.
Yeah.
These are quite specialized and involve combustible metals. We're talking magnesium, titanium, zirconium, sodium, lithium, potassium.
Things you might find in, like, machine shops or labs.
Exactly. These metals react very differently than ordinary combustibles or liquids. Applying the wrong agent, even water, can be incredibly dangerous, causing explosions or worsening the fire significantly. They require very specialized extinguishing agents. And finally, Class K fires. The K stands for kitchen.
Makes sense.
These fires occur specifically in cooking appliances involving combustible cooking media that's vegetable or animal oils and fats. Think deep fat fryers in commercial kitchens, or a pot of oil that catches fire on your stove at home.
Right, the dreaded grease fire.
Precisely. Traditional Class B extinguishers often aren't effective or safe on these high-temperature reigniting fires, which is why this distinct class, Class K, was created.
Okay, A, B, C, D, K. That covers a lot. So a multi-purpose extinguisher might be labeled ABC, indicating its versatility across those common types of fires, which is incredibly helpful for general use.
Correct. That's very common.
But knowing these distinctions is crucial because, as you mentioned, picking the wrong agent can be dangerous. Let's dig into the different extinguishing agents now and their suitability for these fire classes. It sounds like a precise science.
It absolutely is a precise science. The agent inside the extinguisher must match the fire class for effective and safe extinguishment. Using the wrong agent can not only be ineffective, but it can actually escalate the hazard, turning a manageable situation into a dangerous one.
Right. So what are the main types of agents?
Let's walk through the main types. First, water types. These are primarily for Class A fires. They work mainly by cooling the fuel below its ignition temperature and soaking the material to prevent reignition.
Just plain water.
It can be plain water, but this category also includes solutions with antifreeze for cold environments, maybe wetting agents to help water penetrate deeper into materials, or loaded stream charges, which use an alkali metal salt as a freezing point depressant. Crucially, though, water should never be used on Class B fires. It can spread flammable liquids or Class C fires due to the severe electrical shock hazard. And it's also dangerous on Class D and K fires because of potential chemical reactions or splashing.
Okay, water for Class A mostly. What's next?
Carbon dioxide, CO2. This agent is suitable for Class B and C fires. CO2 is a colorless, odorless, electrically non-conductive inert gas. It extinguishes fire by rapidly displacing the oxygen concentration in the air around the fire, basically smothering it.
Takes away the oxygen.
Exactly. When discharged, it forms dry ice snow, which also provides some cooling effect. However, it has a limited range and can be affected by wind. And a big safety point: prolonged use in unventilated or confined spaces can lead to oxygen deficiency and loss of consciousness for the operator.
That's a serious risk.
It is. Got to be careful with CO2 indoors. Next up, dry chemical. This is probably what most people think of. A finely powdered agent, typically based on sodium bicarbonate, potassium bicarbonate, or ammonium phosphate. These are incredibly versatile, but there are important distinctions within this category. Okay? You have ordinary dry chemical agents, which are effective on Class B and C fires. They work by interrupting the chemical chain reaction of the fire.
Stops the fire chemistry.
Pretty much. Then you have multi-purpose dry chemical agents, which contain ammonium phosphate. These are effective on Class A, B, and C fires. The ammonium phosphate actually softens and adheres to Class A materials, forming a smothering coating, in addition to interrupting the chemical reaction for B and C fires.
So the ABC ones cover more bases.
They do, but here's a critical safety note. You should never mix different dry chemicals in an extinguisher.
Why not?
It can cause dangerous pressure buildup due to chemical reactions within the cylinder itself. This isn't just a recommendation, it's a critical safety directive in the standard.
Yeah.
Very dangerous.
Right, don't mix them. Got it. What about kitchen fires specifically?
For those Class K fires, you need wet chemical agents.
Yeah.
This is an aqueous solution of organic or inorganic salts, primarily designed for Class K fires. It works through a process often called saponification.
Saponification, like soap.
Exactly like making soap. Think of it like turning hot grease into a thick, soamy soap blanket over the burning oils and fats. This cools them and prevents reignition, which is a big problem with grease fires.
Okay.
These agents are specifically formulated for the high-efficiency cooking appliances and hotter-burning vegetable shortenings found in modern commercial kitchens. And a crucial detail from the standard. Class K extinguishers manufactured after January 1, 2002 shall not use extended one-type discharge devices to prevent dangerous splashing of hot grease onto the operator or surrounding areas.
Good safety point. Avoid the splashback.
Definitely. Then there are halogenated agents, often called clean agents. These are extremely useful for Class B and C fires, and some even have an A rating. This category includes halocarbons, a family of chemical gases like HCFCs, HFCs, PFCs, FIC types, and the older halons like halon 1211 and 1301.
Clean agents. Why clean?
Because they are electrically non-conducting, volatile or gaseous, and most importantly, they leave absolutely no residue upon evaporation.
Okay, so they don't make a mess.
Exactly. This makes them ideal for protecting delicate electronic equipment, data centers, telecom rooms, museums, archives, anywhere where residue from other agents would cause significant expensive damage.
Makes sense. But weren't halons phased out?
Yes, halon production ceased in 1994 due to concerns about ozone depletion, mandated by the Montreal Protocol. But existing units, if properly maintained, are still listed, and the recovered halon can be reused through closed recovery systems. The newer halocarbons are the modern replacements. Nearly there. Dry powder. These are solid materials in powder or granular form, specifically for Class D combustible metal fires.
Only for metals.
Only for metals. They work by crusting over the metal, smothering it, or transferring heat away. It's critical that the agent used is compatible with the specific metal, as reactions can vary dramatically. You'll often find these applied by scoop or shovel from a pail, not necessarily a pressurized cylinder. And finally, water mist. This type discharges distilled or deionized water as a very fine spray, like a fog.
Tiny droplets.
Very tiny. It's suitable for Class A and C fires, and, like clean agents, leaves no residue. This makes it particularly valuable where contaminants in regular tap water could damage sensitive equipment, like in operating rooms, museums, or clean rooms, where purity is paramount. It works by cooling and some oxygen displacement.
That's an incredible array of tools, each with a very specific purpose. It really drives home the point that picking the wrong type can be worse than having no extinguisher at all.
Absolutely.
And what about older extinguishers, the ones that might still be hanging around in someone's garage, or a dusty corner of a workshop, or an old building? Does NFPA 10 have a remove from service list?
Yeah.
This is fascinating because these devices aren't like fine wine. They don't get better with age.
You hit on an extremely important safety point for our listeners.
Yes.
Yes, NFPA 10 provides a clear and mandatory list of obsolete types that shall be removed from service. This isn't just about inefficiency. It's because many of these older models are either ineffective, dangerous, or both.
Dangerous.
Yes. Seriously dangerous in some cases. If you have one of these or spot one at work, this is a crucial takeaway for you to address it immediately. Don't ignore it.
Okay, so what's on this hit list? What should people look out for?
The list of extinguishers that shall be removed from service includes some truly historical and now hazardous items. First, soda acid extinguishers. These were very early types. Chemical foam extinguishers, excluding the modern film-forming agents. These older foam types are prone to internal corrosion and can fail dangerously under pressure, and a particularly grim category. Extinguishers containing carbon tetrachloride, methyl bromide, and chlorobutylmethane, CBM.
Carbon tet, I've heard of that. Isn't it toxic?
Extremely. These aren't just ineffective, they're lethally dangerous. When these chemicals hit fire, they release highly toxic gases, like phosgene gas in some cases. Using one could turn a bad situation into a potentially fatal one for anyone nearby, including the operator.
Wow. Okay, definitely get rid of those. What else?
Also on the list, cartridge-operated water and cartridge-operated loaded stream types. Extinguishers with copper or brass shells joined by soft solder or rivets, with the exception of pump tanks. The structural integrity of these older designs is often compromised over time, making them a rupture hazard.
Could literally explode.
Potentially, yes, under pressure or if damaged. Carbon dioxide extinguishers with metal horns. The metal can become extremely cold during discharge, posing a risk of severe frostbite to the user's hands. Modern ones use plastic or composite horns. Solid charge type AFFF extinguishers that use a paper cartridge to generate the foam. Pressurized water fire extinguishers manufactured prior to 1971. These older models simply do not meet current safety standards for pressure vessels. Any extinguisher that needs to be inverted to operate. Remember those old ones you had to flip upside down?
Yeah, I think I've seen pictures.
They're awkward, slow, and just not efficient in an emergency. Obsolete. Any extinguisher manufactured prior to 1955. The materials and manufacturing processes of that era just don't meet modern safety or performance benchmarks. Finally, any extinguishers with older, no longer recognized 4B, 6B, 8B, 12B, and 16B fire ratings. These older ratings are obsolete and don't accurately reflect current extinguishing capabilities tested under modern standards.
That's a chilling thought, especially regarding those toxic agents like carbon tet. So if someone is listening right now and they think they might have one of these older, truly hazardous types in their garage or workshop, what's the immediate non-negotiable step they need to take? This isn't just about an old piece of equipment, it's about a real danger.
The immediate non-negotiable step is to remove it from service immediately and dispose of it properly and safely. Usually this means taking it to a local hazardous waste facility or contacting a licensed fire equipment dealer who specializes in safe disposal.
Don't just throw it in the trash.
Absolutely not, especially not the toxic ones or pressurized ones. And definitely do not try to test it or discharge it yourself, especially if it's one of the types that produces toxic fumes. This is a direct action point for you, our listeners, to enhance your safety. Check your old extinguishers.
Good advice. Okay, so beyond the actual extinguisher unit itself, what general requirements does NFPA 10 have regarding the labels and instruction manuals? This sounds like vital information for the owner or user.
It absolutely is. Clear and accurate labeling, along with accessible instruction manuals, are fundamental for safe and effective use. All listed and labeled extinguishers, according to NFPA 10, shall have specific information visibly affixed. This isn't just about identifying the contents, but also understanding potential hazards and how to contact the manufacturer if needed.
But what needs to be on that label?
Specifically, the label, tag, or stencil attached to the extinguisher shall provide several key pieces of information. 1. The content's product name as it appears on the manufacturer's Material Safety Data Sheet, or MSDS, now often called Safety Data Sheet, SDS.
Okay, the chemical name.
Right. This is crucial for emergency responders to quickly understand the chemical composition if the agent is released or if the situation escalates. 2. Hazardous Material Identification System, HMIS, information, or for our Canadian listeners, the Globally Harmonized System, GHS. These are critical labeling systems that use numerical indexes, usually 0 to 4, to detail toxic properties, flammability, and reactivity.
The little colored diamond label sometimes.
That's related, yeah. It helps quickly assess the hazards. Most extinguisher agents are non-flammable and relatively inert, showing low numbers here. But this information is vital for understanding potential risks if the agent is misused or released. 3. A list of hazardous chemicals exceeding 1.0% of the contents, and a separate list of each chemical in excess of 5.0% of the contents. 4. Information as to what is hazardous about the agent in accordance with the MSDS-SDS, summarizing key safety data. 5. And finally, the manufacturer's or service agency's name, mailing address, and phone number. This ensures accountability and provides a clear point of contact for service or any questions.
So a lot of info packed onto that label. What about the manual?
Beyond these labels, an instruction manual is also a mandatory component. The owner or the owner's agent shall be provided with a fire extinguisher instruction manual. This manual details condensed instructions and cautions necessary for the proper installation, operation, inspection, and maintenance of the fire extinguisher.
The quick start guide, basically.
More than that, really. It should cover everything. And critically, the manual shall refer to NFPA 10 as a source of detailed instruction. This places a clear responsibility on the owner to read and understand this information, ensuring they are prepared not just to have the extinguisher, but to use and maintain it correctly and safely.
Strategic placement and ready for action installation and operation.
Okay, so we've identified the different classes of fires, A, B, C, D, K. We've talked about the various extinguishing agents, water, CO2, dry chem, wet chem, clean agents. We even understand the vital labeling requirements. Now, the next crucial puzzle piece. How do we match them to a specific location or hazard? Because it's not just about having an extinguisher, but having the right one in the right place, accessible, and ready when you need it.
Exactly. The selection process is incredibly meticulous, designed to ensure maximum effectiveness and safety. First, it's crucial to understand that the selection of portable extinguishers shall be independent of whether a building has automatic sprinklers, standpipe and hose systems, or other fixed fire protection systems.
So even if you have sprinklers, you still need portables.
Absolutely. Portable extinguishers are considered a first line of defense for limited-sized fires. They offer immediate intervention before larger automated systems might activate or even be needed. They're your quick response tool for small, incipient stage fires.
Got it. First responders, in a way.
In a way, yes, for the occupants. Now, to guide selection, we classify occupancy hazards into three main categories, reflecting the potential type and quantity of fuel for a fire. Light hazard. These are areas where the amount and combustibility of ordinary combustible materials, Class A, are low, and Class B flammables are limited. Think quiet offices, classrooms, churches, assembly halls, places where the primary fire risk might be paper, fabrics, or small electrical items.
Lower risk areas.
Generally, yes, ordinary hazard. This applies to occupancies where the amount and combustibility of ordinary combustible materials are moderate, and Class B flammables might be present in greater quantities. Examples include light manufacturing facilities, auto showrooms, parking garages, research labs, retail stores. Here, fires could be more substantial, but still generally manageable with the right extinguisher.
Medium risk.
You could say that. Extra hazard. These are areas where the amount and combustibility of ordinary combustible materials are high, or where Class B flammables are present in significant quantities and used frequently. This category encompasses woodworking shops, vehicle repair facilities, aircraft servicing areas, commercial cooking operations, facilities handling large volumes of flammable liquids, or warehousing of high-hazard commodities like plastics or flammable liquids.
High risk, potentially fast-spreading fires.
Exactly. These are places where a fire can quickly become very intense and widespread, requiring more significant extinguishing capability.
Okay, so those are broad categories. What about specific types of hazards? Does this standard get more granular?
Oh, absolutely. Beyond these general occupancy hazards, NFPA 10 has very specific and critical requirements for certain types of hazards. This is where the standard truly gets detailed to ensure the right agent is used. For Class K cooking media fires, as we discussed, only Class K listed and labeled extinguishers shall be used. Traditional extinguishers just won't cut it safely or effectively.
Right, the sponification thing.
Exactly. And here's a detail people often miss, especially in commercial kitchens. If that kitchen also has an automatic fire suppression system, like those nozzles built into the ventilation hood.
You mean those ceiling sprinklers or hood systems that automatically discharge?
Exactly. If one of those is present and protects the same hazard, the standard requires a sign to be placed near the portable extinguisher saying something like, actuate the fixed system first.
Really? Use the big system before the handheld.
Yes. It might seem counterintuitive to some, but that fixed system is designed to hit the fire with massive force and coverage, far more than you typically can with a handheld extinguisher. It's that primary, bigger weapon you want firing first, especially on a potentially fast-spreading grease fire. It's a subtle point, but could be the difference between a contained fire and an out-of-control disaster.
Okay, that's a really important operational note for commercial kitchens. What about electronics?
For electronic equipment fires. When protecting delicate equipment like telecommunications gear, computers, servers, robotics, medical equipment, extinguishers shall be selected from types specifically listed for Class C hazards. That means they're non-conductive. But critically, dry chemical extinguishers shall not be installed for protection of delicate electronic equipment.
Why not? They're often rated ABC, right?
They are, but the residue they leave behind is incredibly fine, pervasive, and often corrosive. It can get into everything and cause far more long-term damage to sensitive electronics than the initial small fire might have. Cleanup is a nightmare, if even possible.
So what should be used instead?
Water mist or halogenated clean agents are the preferred choice here because they are electrically non-conducting and, crucially, leave no residue. Much safer for the equipment.
Good to know. Any other specific areas?
Yes, for areas containing oxidizers. This includes situations like storage areas for pool chemicals containing chlorine or bromine or other strong oxidizing agents. In these specific environments, only water or foam extinguishers shall be installed.
Why only water or foam?
Because other agents, particularly dry chemicals, could react dangerously or even catastrophically with strong oxidizers, creating an even worse hazard, potentially releasing toxic gases or accelerating the fire.
Wow, okay. Very specific chemistry involved.
Very specific. For Class D combustible metal fires, as discussed, the agents must be compatible with the specific metal for which protection is provided and should be listed and labeled for that metal. There's no one-size-fits-all solution for metal fires because each metal reacts uniquely. Using the wrong powder could be ineffective or even make things worse. And finally, wheeled fire extinguishers. These Lozier units aren't a specific hazard type, but they're considered for high hazard areas like extra hazard occupancies, or where limited personnel mean you need significantly higher agent flow rates, an increased agent stream range, and much greater agent capacity to combat a larger or more persistent fire. They provide significantly more firefighting capability than hand-portable units and are often seen in industrial settings, warehouses, or airport ramps.
This sounds like a truly comprehensive approach to matching the tool to the task, leaving very little to chance. Once selected, based on the hazard, where exactly do we put them? It can't just be anywhere, stuck in a closet, right? Placement must be absolutely key for immediate and effective response.
You're absolutely right. Placement is just as critical as selection. Even the best extinguisher is useless if it can't be found or accessed quickly when seconds count. The minimum number of extinguishers required depends on the hazard classification, light, ordinary, extra, and the area to be protected, often based on maximum travel distance to an extinguisher, which varies by hazard class.
So you need enough of them, close enough to where a fire might start.
Exactly. And NFPA 10 lays out specific installation requirements to ensure they're ready when you need them. Visibility and access. Extinguishers shall be conspicuously located where they will be readily accessible and immediately available in the event of fire. Preferably along normal paths of travel, including exits, they shall not be obstructed or obscured from view.
No hiding them behind furniture or equipment.
Definitely not. Imagine trying to get to one during a fire. You don't want to be fighting obstacles. If they are placed inside a cabinet, the cabinet shall be marked conspicuously. Or if the extinguisher itself is visible through the cabinet door, that's acceptable. Clear signs shall indicate its location if it's not immediately obvious, ensuring no time is wasted searching in an emergency. Mounting height. To ensure ease of access for a wide range of users, there are specific height requirements. For extinguishers weighing 40 pounds, approximately 18 kilograms or less, the top of the extinguisher shouldn't be more than 5 feet, about 1.5 meters above the floor.
Okay, within easy reach.
Right. For those heavier ones, over 40 pounds, excluding wheeled types, the top must be lower, no more than 3.5 feet, about 1 meter above the floor. And in no case shall the bottom of the extinguisher be less than 4 inches, about 10 centimeters from the floor. This keeps it off the ground, preventing corrosion and making it easier to grab, while ensuring it's reachable for most adults. Label visibility. This is important for quick use. The operating instructions must face outward so an operator can quickly read them in an emergency without fumbling or turning the extinguisher around.
Makes sense. Don't want to be reading the back label.
Exactly. Other labels, such as Hazardous Material Identification System, HMIS labels, 6-year maintenance labels, or hydrostatic test labels, shall not be located or placed on the front of the extinguisher. The only exceptions are original manufacturer labels or labels that specifically relate to the extinguisher's operation or fire classification, or maybe small inventory control labels specific to that extinguisher. This ensures the most critical information, how to operate it, is immediately visible and not obscure. Cabinets. If extinguishers are housed in cabinets, these cabinets shall not be locked unless the extinguishers are subject to malicious use, like maybe in a school or public area.
Okay, but if they are locked?
Then the cabinet shall include a clear, immediate means of emergency access. For example, cabinets with break front panels shall be provided with breaker bars or hammers attached nearby. For extinguishers exposed to elevated temperatures, the cabinets shall be provided with screened openings and drains to prevent overheating and maintain agent effectiveness. And a note for new installations, if you're putting a cabinet in a fire resistance rated wall, only surface-mounted cabinets or properly listed fire-rated cabinets are allowed to maintain the wall's fire barrier integrity. Temperature exposure. This is critical for performance. Extinguishers shall not be exposed to temperatures outside their listed temperature range as shown on the label. Extreme cold or heat can affect the pressure, the agent itself, or the extinguisher components.
So you need the right type for, say, an unheated warehouse in winter.
Precisely. Or for an area near intense heat. For example, AFFF, aqueous film-forming foam, and FFP, film-forming fluoroprotein foam, phone agents, cannot be protected against freezing by simply adding antifreeze, as it destroys their effectiveness. Also, calcium chloride solutions, sometimes used as antifreeze in water extinguishers, should not be used in stainless steel fire extinguishers due to severe corrosion risks. This attention to detail ensures the agent performs as expected in varying environmental conditions. Electronic monitoring. Finally, if an electronic monitoring system is installed, perhaps to track if the extinguisher is removed from its location or if its pressure drops, the connection to the device and its power source shall be continuously supervised for integrity. This means the monitoring system itself must always be operational and reliable, ensuring alerts are actually sent if there's an issue.
That level of detail truly ensures they are not only present, but also effective and safe when an emergency strikes. But the best selected and best installed extinguisher is useless if the person grabbing it doesn't know what to do. So let's talk about operating a portable fire extinguisher. What are the basic steps that NFPA 10 guides us through? I know we mentioned the pass method earlier. This is arguably the most critical part for the individual user in that moment of crisis.
This is indeed the most crucial part for the individual user because in a real fire, there's very little time for hesitation or error. The standard heavily emphasizes familiarizing yourself with the manufacturer's instructions before an emergency happens. Read the label on the extinguisher you might actually use.
Be prepared beforehand.
Exactly. While different types of extinguishers have nuances in how they feel or discharge, the basic steps for operation often boil down to that easily remembered PASS acronym, or an equivalent set of actions designed for quick recall in a crisis. P, pull the pin. The first step is to remove the safety or locking device. This is usually a pin inserted through the handle levers, often held in place by a plastic tamper seal that breaks when you pull the pin.
Just yank it out.
Pretty much. The standard requires that a maximum of 30 pounds of force should be sufficient to remove this pin, making it accessible to most adults, even under stress. Pull straight out. Aim the nozzle. Direct the nozzle, horn, or hose at the base of the fire. Not the flames themselves, but where the fuel is burning.
Attack the source.
Exactly. You're trying to extinguish the fuel source directly, not just bat down the visible fire. Think of it as attacking the root of the problem, not just the leaves. Aim low at the base. S, squeeze the handle. Depress the operating lever or handle smoothly and evenly. This releases the internal pressure and sends the extinguishing agent towards the fire. Maintain a firm grip. On some types, like CO2, there might be a secondary trigger handle.
Squeeze it all the way.
Generally, yes. Fully depress the lever for maximum flow. S, sweep from side to side. Move the nozzle or horn across the base of the fire in a slow, sweeping motion. Start at the closest edge and work your way across. This ensures coverage over the entire burning area. Keep sweeping until the fire appears to be out.
Keep going even if it looks out.
Yes, watch carefully for reignition and continue discharging if necessary. And sometimes people add another P position. Start close enough to the fire to be effective, but not so close you're in danger or causing splashback, especially with liquids. The effective range is usually printed on the label, often several feet. Then move closer as the fire subsides. For contained flammable liquid fires, like in a pan, you should start at the near edge and sweep the agent gently across the surface, gradually progressing toward the back of the fire, trying to push the fire away from you. For deep-seated Class A fires, like smoldering upholstery or trash, it's often necessary to break apart the burning material with the agent stream or a tool if safe to ensure complete extinguishment of any hidden embers.
Good tips. Are there other operational things to keep in mind?
Yes, some other key operational points to remember which highlight the urgency and the risks involved. Many portable extinguishers discharge their entire content in a very short amount of time, often just 8 to 10 seconds for smaller units, maybe up to 30 seconds for larger hand portables. Wheeled units last longer.
That's not much time.
Not at all. This means you have very little time for error or to figure things out. Practice, if possible, even just mentally walking through the steps is invaluable. Know where your nearest extinguisher is and how it works before you need it. On flammable liquid fires, Class B, the fire can actually flare up momentarily when the agent is first applied due to the disruption of the vapor layer. This is a normal reaction and shouldn't cause the operator to stop or panic. Keep swooping. If you're using carbon dioxide, CO2 agents, remember what we said earlier, they displace oxygen. Prolonged use in unventilated or confined spaces can lead to oxygen deficiency and potentially loss of consciousness. Always ensure ventilation if possible and be ready to evacuate immediately after use. And finally, a reminder, water-based agents should never be used on energized electrical equipment, Class C, due to the severe electrical shock hazards. Always ensure the equipment is de-energized first, if possible, or use a Class C rated extinguisher designed for electrical fires, like CO2, dry chemical, clean agent, or water mist.
So it's not just having it, but knowing how to use it quickly, correctly, and safely, understanding its limitations and potential dangers. This brings us to the crucial aspect of ensuring these devices are always ready for action, day in, day out, which means inspection, maintenance, and testing.
Maintaining readiness inspection, maintenance, recharging, and testing.
Right. So if having an extinguisher and knowing how to use it are critical, ensuring it's actually ready for use when that moment strikes is absolutely paramount. What's the fundamental difference, again, between that quick visual check of the inspection and a deeper professional tune-up? The maintenance. NFPA 10 clearly defines them.
This distinction is incredibly important because it dictates who can perform the task, how thoroughly it needs to be done, and how often, directly impacting the safety and reliability of the extinguisher. The owner or their designated agent, often a responsible employee or facilities manager, is responsible for ensuring regular inspections are performed.
Okay, the owner is responsible for inspections. How often?
For inspections, which are essentially those quick visual checks, frequency. Extinguishers shall be inspected manually when initially placed in service. After that, they shall be inspected at intervals not exceeding 31 days effectively, at least once per calendar month.
Once a month. Minimum.
Minimum. More frequent inspections, daily or weekly, are required if conditions warrant. Think about areas with a high frequency of fires in the past, severe hazards, or a significant risk of tampering or vandalism, like maybe a construction site or a public access area.
Makes sense. Check more often if the risk is higher. Who can do this monthly check?
This is key. Persons performing inspections are not required to be certified according to NFPA 10.
Ah, okay.
This means a diligent homeowner, a building manager, or a trained employee can perform this check, provided they understand what to look for based on the standard and manufacturer guidance.
So what are they looking for in this monthly inspection?
The inspection involves checking a specific list of items. 1. Verify the extinguisher is in its designated location. 2. Ensure it's clearly visible and accessible, no obstructions. 3. Check that the pressure gauge reading or indicator is in the operable range or position for stored pressure types. 4. Determine if it's full. This might be done by weighing or hefting, lifting to feel the weight, especially for CO2 or halon types which don't typically have gauges. 5. Examine the physical condition. Look for obvious damage like corrosion, leakage, or a clogged nozzle. For wheeled units, check the tires, wheels, carriage, hose, and nozzle assembly. 5. Examine the physical condition. 6. Check that the operating instructions on the nameplate are legible and face outward. 5. Examine the physical condition. 7. Verify that the tamper indicators and seals are intact, not broken or missing. For Class D agent containers, like pails, verify the lid is properly sealed.
Pretty thorough visual check, actually. What if they find something wrong?
If an inspection reveals any deficiency, low pressure, damage, missing pin, anything, immediate corrective action shall be taken. This isn't something to put on a to-do list for later.
What kind of corrective action?
For rechargeable extinguishers, this means subjecting it to the applicable maintenance procedures, which must be performed by a certified professional. For non-rechargeable dry chemical extinguishers found deficient, it means removing it from service, discharging it safely, if possible, away from people or sensitive areas, and then destroying it so it can't be reused. For non-rechargeable halon agent extinguishers, it means removing it from service but not discharging it into the atmosphere. Instead, it shall be returned to the manufacturer or a qualified fire equipment dealer for proper halon recovery due to its environmental impact.
Okay, different actions depending on the type. Do you need to log these inspections?
Yes. Record keeping is required. Manual or electronic event logs shall be maintained to document these monthly inspections, including the date and the initials or identification of the person performing the inspection. This provides a clear, auditable trail of readiness and accountability.
That makes a lot of sense. So, inspections are about making sure nothing obvious is wrong, done monthly, and can potentially be done in-house. But when it comes to the deeper, more thorough check, the maintenance, this sounds like where the certified professionals with specialized knowledge really come in.
Precisely. Maintenance is where the specialized expertise, training, and equipment of certified professionals become absolutely critical. Persons performing maintenance and recharging shall be certified according to NFPA 10.
Certified. How does one get certified?
Certification typically requires passing a comprehensive test administered by an organization acceptable to the AHJ, authority having jurisdiction. And that test, at a minimum, is based upon in-depth knowledge of all the chapters and annexes of NFPA 10. It's not just memorizing facts. They need to demonstrate the ability to apply the standard during the test, often including hands-on procedures. They need the right tools, recharge agents, lubricants, and manufacturer-specific service manuals. It's a professional qualification.
Okay, so this is a job for the pros. How often does maintenance need to happen?
Regarding maintenance, it's a much deeper dive into the extinguisher's health. Frequency. Maintenance shall be performed at intervals not more than 1 year, so annually, or at the time of a hydrostatic test, or whenever an inspection discrepancy or electronic notification indicates a potential problem. So at least once a year, or sooner if needed.
Annually. What does maintenance involve that inspection doesn't?
Maintenance is a far more thorough examination than an inspection. It includes all the detailed procedures outlined in the manufacturer's specific service manual for that model, plus a comprehensive look at every basic element of the extinguisher. All mechanical parts, like the valve assembly, discharge lever, carrying handle, the extinguishing agent itself, checking for proper fill and condition, the expelling means, like the pressure cartridge or stored pressure level, and the overall physical condition.
So they take it apart.
Sometimes, yes, depending on the type and the interval. Specific checks involve looking for subtle cylinder dents, internal or external corrosion, which might require emptying the agent, ensuring legible and correct nameplates, proper pull-pin function, smooth removal, operable handles and levers, clear and unobstructed nozzles or horns, verifying the proper weight of the agent and pressure, and always replacing the tamper seal with a new listed one after maintenance is complete.
Sounds very thorough. You mentioned internal examination.
Yes, for certain types of extinguishers, an internal examination of the cylinder is required at specific intervals. This is a significant undertaking, involving completely depressurizing and disassembling the extinguisher to look inside for corrosion or other issues.
Which types and how often?
For stored pressure water, AFFFFFFP foam, and wet chemical extinguishers, this internal exam is required every 5 years. For dry chemical, dry powder, and halogenated agent extinguishers that have mild steel shells, also some others like cartridge-operated dry chem, it's typically every 12 years. This ensures the internal components and the agent itself haven't deteriorated in ways that wouldn't be visible from the outside. It's a critical check for long-term safety.
5 or 12 years, depending on the type. Okay. What about the hoses?
Good question, especially for wheeled units. Their discharge hoses must be completely uncoiled and examined for damage, cracks, cuts, coupling issues annually. Then they need to be recoiled carefully in a way that prevents kinks and allows rapid deployment in an emergency. Carbon dioxide hose assemblies have an additional crucial requirement. They need an annual conductivity test.
Conductivity test. Wow.
Because the discharge of CO2 can generate significant static electricity. If the hose assembly isn't sufficiently conductive to ground that static safely, it could potentially discharge to the operator, causing a shock, or even ignite flammable vapors if present. So that test ensures the hose is safe from an electrical standpoint.
Wow, another detail I wouldn't have thought of. And electronic monitoring systems.
Any electronic monitoring systems for extinguishers shall also be inspected and maintained according to Section 7.6 of the standard and the manufacturer's manuals, ensuring the system itself, the sensors, wiring, power, communication link, is always functional and reliable.
That's a deep dive into maintaining readiness. What happens after an extinguisher has been used, even partially, or reaches a specific interval that requires its agent to be refreshed? That's where recharging comes in, I assume. And again, this sounds like another job for those certified professionals.
That's exactly right. Recharging is the process of replacing the extinguishing agent, and for some types also the expellant gas, after an extinguisher has been used, even if only for a second, or if its agent integrity is compromised due to time or contamination. And just like maintenance, recharging must be performed by certified personnel. They need the correct tools, proper recharge materials, the right agent, lubricants, and, crucially, the manufacturer's specific instructions for that particular model. This is absolutely not a DIY job for a homeowner or untrained employee.
Okay, certified pros only. How often does recharging need to happen, besides after use?
The standard specifies recharge intervals for certain types, even if they haven't been used. For example, pump tank water and pump tank antifreeze types shall be recharged every 12 months with new chemicals or fresh water as appropriate. Wetting agent additives and stored pressure water extinguishers shall be replaced annually. Pre-mixed AFFF and FFFP foam agents shall be replaced at least every 5 years, or as the manufacturer instructs, though an exception allows for agent analysis by a competent lab to potentially extend that, but generally it's every 5 years.
So some agents have a shelf life, essentially.
Exactly. Their effectiveness can degrade over time. Agent integrity during recharge is absolutely paramount. A crucial rule we mentioned before. You shall never mix different types of dry chemical agents. Doing so can cause a dangerous chemical reaction inside the cylinder, leading to pressure buildup and potentially catastrophic failure.
Worth repeating that one.
Definitely. For all non-water types of fire extinguishers, any moisture shall be removed from the cylinder before recharging. Moisture can lead to severe internal corrosion and cause agents like dry chemical to clump or cake, making them unusable when needed. In CO2 and halogenated extinguishers, moisture can combine with the agent to form corrosive acids, damaging the cylinder from the inside out.
So keeping them dry inside is critical.
Yeah, absolutely critical. Dry powder agents for Class D metal fires shall be kept absolutely dry. Damp powder can react dangerously with combustible metals, actually worsening a fire instead of extinguishing it. Halogenated agents like halon replacements shall be recovered using closed recovery systems during maintenance and recharging to prevent their release into the atmosphere due to environmental regulations. They can only be reused if no internal contamination is observed after internal examination. Carbon dioxide used for recharging shall meet strict purity standards. At least 99.5% pure CO2 with very low water content, not more than 60 parts per million by weight, and oil content, not to exceed 10 ppm by weight. This meticulous purity ensures the agent performs as expected and doesn't introduce contaminants that could cause malfunction or corrosion.
Wow, strict purity for CO2. What about the gas used to pressurize them?
Good point. For expellant gas in stored pressure extinguishers, they shall only be repressurized with the type of expellant gas referred to on the extinguisher label. Usually this is nitrogen or dry air for most types.
Not just any compressed air.
No. And this is a significant safety update in recent versions of the standard. You shall never use unregulated compressed air from a standard shop compressor for pressurizing non-water types, even if some very old instructions might have suggested it.
Why not?
Because regular compressed air contains moisture and often oil contaminants, which, as we just discussed, are bad for the extinguisher and agent. Also, the pressure control on shop compressors can be unreliable, potentially overpressurizing the cylinder, which is incredibly dangerous. Compressed air is only permitted for recharging water and foam hand extinguishers, and only if it's supplied through a regulated source with effective moisture traps.
Okay, use the right gas, regulated pressure. What's this about a service collar?
The service collar. After any maintenance procedure that involves internal examination or recharging that requires the removal of the valve assembly, which is most maintenance or charge on stored pressure types, a verification of service collar shall be installed around the neck of the container underneath the valve assembly.
What does it look like?
It's usually a plastic ring that sits on the neck. It provides a visible, permanent record that the extinguisher has been professionally opened and serviced. The collar typically shows the month and year the service was performed and the identity of the service company. Pumped tank extinguishers are an exception to this requirement, as they don't hold constant pressure and aren't disassembled in the same way for recharge.
So it's proof of internal service.
Exactly. It helps ensure accountability and track service history.
That's incredibly thorough, detailing every step to ensure the agent and expellant are perfect. But even with the best maintenance and recharging, the physical integrity of the extinguisher cylinder itself needs to be verified over time, right? This sounds serious, testing the strength of the pressure vessel itself through hydrostatic testing.
It is indeed very serious and absolutely essential for safety. Hydrostatic testing verifies the structural strength of the extinguisher cylinder and its associated hose assemblies against unwanted rupture. Remember, these are pressure vessels, sometimes holding hundreds of pounds per square inch of pressure. A failure under pressure can be catastrophic, turning the cylinder into shrapnel.
Okay, so how does this test work? What do they actually do?
The procedure for a hydrostatic test always includes both an internal and an external visual examination of the cylinder first, looking for any signs of damage, corrosion, pitting, dents, arc burns, or other defects that might compromise its integrity.
So they look closely first.
Yes. Then, crucially, water or another compatible non-compressible fluid is the test medium. Air or other gases shall not be used as the sole medium for pressure testing.
Why only liquid?
This is a critical safety point. Air and other gases are highly compressible, meaning they store a tremendous amount of energy when pressurized. If a cylinder tested with high-pressure air were to fail, that stored energy would release explosively, violently, potentially causing severe injury or death. Water, being non-compressible, stores very little energy, so if a cylinder fails during a water-based hydro test, it typically just leaks or splits without that explosive force. Much, much safer.
Makes perfect sense. Safety first.
Absolutely. All air shall be vented from the cylinder before hydrostatic testing begins to prevent dangerous pockets of compressed air. Furthermore, there's a specific rule for aluminum. If a fire extinguisher has an aluminum cylinder or shell and is suspected of being exposed to temperatures in excess of 350 degrees F, 177 degrees C, it was involved in or very near a fire, it shall be removed from service and subjected to a hydrostatic test before being put back in service. High heat can weaken aluminum significantly, making it potentially unsafe, even if it looks okay.
Okay, so visual checks, then pressure test with water. How often does this need to be done?
The frequency of hydrostatic retesting varies significantly by extinguisher type, reflecting the different materials, steel, aluminum, stainless steel, construction methods and agents involved, and their susceptibility to wear, corrosion, and stress over time. Types like stored pressure water, CO2, AFFFFFFP, foam, wet chemical and dry chemical extinguishers with stainless steel shells shall be hydrostatically tested every 5 years.
5 years for those.
Right. For other common types, such as stored pressure, dry chemical with mild steel, brazed brass, or aluminum shells, as well as halogenated agent extinguishers and dry powder extinguishers, for the cylinder, not the agent, the interval is longer, every 12 years.
12 years, okay.
Hose assemblies that are equipped with a shut-off nozzle, meaning they hold pressure, are generally tested at the same interval as the extinguisher cylinder they're attached to, as they are also pressure-bearing components.
5 or 12 years, depending. What happens if it fails the test?
This is the ultimate safety measure: condemnation. If an extinguisher cylinder, shell, or cartridge fails a hydrostatic pressure test, meaning it leaks, bulges, distorts significantly, or ruptures under the test pressure, or if it fails the initial visual examination due to conditions like cracks, severe corrosion, especially pitting, evidence of being damaged in a fire, or excessive dents or damage, it shall be condemned or destroyed.
No fixing it.
Absolutely not. A condemned cylinder shall not be repaired under any circumstances. It must be permanently marked to prevent any possibility of future use. This is typically done by stamping condemned on the top, head, shoulder, or neck with a steel stamp with minimum letter height of 18-inch, 3 millimeter. It's then usually destroyed by the testing facility, often by drilling or cutting, to ensure it can never be accidentally put back into service. This ensures that a compromised pressure vessel never poses a risk again. Safety is the absolute priority here.
Bringing it home, residential extinguishers and final thoughts.
We've covered a lot of ground, really digging into the intricacies of NFPA 10 for commercial and industrial settings, with all the testing and certification requirements. But what about us, the homeowners? Does NFPA 10 have specific guidance for portable fire extinguishers in our own residences, especially since most of us, don't have that professional certification or maybe the same level of training?
Absolutely. And it's a vital part of the standard, recognizing that homeowners operate under different circumstances and might have less formal training than professionals in a workplace.
Yeah.
Annex F, specifically, is dedicated to selection of residential fire extinguishing equipment. It's not mandatory code in the same way the main body often is, but it provides strong recommendations.
So it's advice for homeowners.
Yes. The guidance is tailored for ease of understanding and practical application in a residential environment, making it as straightforward as possible for the average person to follow.
So what does it recommend? How many extinguishers should you have at home, and what kind?
The standard provides minimum recommendations for every floor level of a residence to ensure a baseline level of protection. You should have, at minimum, a single extinguisher rated 2A10BC or higher per floor.
2A10BC. What does that rating mean again?
The 2A relates to its effectiveness on ordinary combustibles, like fighting a fire equivalent to 2.5 gallons of water. The 10BC relates to its effectiveness on flammable liquids, like safely extinguishing 10 square feet of burning liquid, and its suitability for energized electrical fires. So that 2A10BC is a good general-purpose workhorse for typical home hazards.
Okay, 1 ABC per floor minimum. Is there another option?
Yes. Alternatively, the annex suggests you can have one extinguisher rated 2A or higher, specifically for ordinary combustibles like wood and paper in living areas or bedrooms. And D, a second extinguisher rated 10 BC or higher, maybe near the kitchen or workshop for flammable liquids and electrical fires. The choice often comes down to what specific hazards are most prevalent in a particular area of your home. Maybe a larger A-rated unit for the living room and a dedicated BC unit near the garage or kitchen.
That makes sense, tailoring it a bit. What about garages? They seem higher risk.
They often are. For areas with higher specific risks, like attached or detached garages, a larger extinguisher, for example, A2, A10, BC, or even higher rating if available, is especially recommended by the annex.
Why bigger for the garage?
It's due to the typically higher volume of flammable liquids normally present in garages. Think about gasoline for your car or lawnmower, stored paints, solvents, cleaning chemicals, maybe propane tanks for a grill. The fuel load is often much higher than inside the house. The increased capacity of a larger extinguisher could be critical there because a fire can spread very quickly with those kinds of fuels.
Good point. And what about those obsolete extinguishers we talked about? Does that list apply to homes too?
Yes, absolutely. And here's a direct action point for you listening at home. The same strict rules for obsolete extinguishers we discussed earlier, the soda acid, carbon tetrachloride, pre-1955 models, the invert-to-use types they also apply to residences. NFPA 10 Annex F explicitly states they should be removed from service and replaced. You shouldn't have dangerous or ineffective equipment lying around your home, especially when modern alternatives are so much safer, more reliable, and usually quite affordable.
Check those old extinguishers in the garage or basement.
Please do. Beyond just having the right equipment, NFPA 10's Annex F outlines crucial safety precautions specifically for home use, which every homeowner should really internalize and discuss with their family. Remember, most fires produce toxic products of combustion, smoke, and gases that can kill you long before the flames do. Therefore, you should always stay low where the air is cleaner and avoid breathing fumes, as well as the extinguishing agents themselves if possible. Protect your lungs. When discharging an extinguisher, particularly on cooking grease fires, Class K, if you get too close, it can cause dangerous splashing of the burning grease or oil, which will spread the fire rapidly. Always follow the label distances for safe operation. Give yourself a safe buffer zone. Don't charge right up to it.
Keep your distance, especially with grease.
Critically important, extinguishers should be accessible near the hazard, meaning easy to get to in an emergency, but not installed directly adjacent to or over the potential hazard. You want to be able to retrieve it safely without reaching over the fire or being in immediate danger. For instance, in a kitchen, it should be mounted near an exit path, not right above the stove where a fire might start.
Good placement advice. Near, but not too near.
Exactly. If using halogenated agent extinguishers, clean agents, at home, which is less common but possible, be aware that they can deplete oxygen and produce thermal decomposition products if the fire is hot enough. The annex advises you must evacuate and ventilate the area immediately after use, just to be safe. And this is the most critical piece of advice for any home fire, big or small, emphasized strongly in the annex. If the fire isn't extinguished very quickly, get out. Close the doors behind you to slow the fire spread, ensure everyone else is out, and do not re-enter the building for any reason. Your life and your family's lives are far more valuable than any property. Always call the fire department immediately, ideally from outside using a cell phone or a neighbor's phone.
That's truly critical advice. Your first priority is always escape and calling for help. Only then, if it's a very small contained fire, you know the extinguisher type is correct, you have a clear escape path, and you feel capable and safe, only then should you attempt to use an extinguisher. Ultimately, it sounds like the standard, even in the annex, is not just about the equipment itself, but about the owner's responsibility of readiness.
Exactly. That phrase captures it perfectly. The ultimate responsibility for the care and use of fire extinguishing equipment, especially in a residential setting, falls squarely on the homeowner or occupant. This isn't just passive ownership, it's an active role.
What does that active role involve?
It includes taking the time to read the owner's manual provided by the manufacturer when you buy an extinguisher, understanding the specific cautions and operating instructions for that model. Crucially, it means instructing family members who might have to use it, show them where it is, how the past method works. You should also perform those simple monthly visual inspections yourself, check the gauge, make sure it's accessible. And while homeowners aren't required to do the annual maintenance or hydro testing themselves, they are responsible for ensuring it gets done if they have rechargeable types, usually by contacting a local fire equipment service company.
So, keep an eye on it, know how to use it, teach others.
Yes. And above all, the homeowner or occupant must ensure everyone in the household knows how to call the fire department, like 911 in the US and Canada, for every fire, no matter how small. This should always be the first step, not an afterthought or something you do only if you can't put it out. Call first, then decide if it's safe to fight it. Owning the equipment is only part of the equation. Understanding it, maintaining it, and knowing when and how to use it, or, just as importantly, when to simply evacuate, is the complete picture of readiness.
So it's a vital partnership. The standard, NFPA 10, sets the meticulous guidelines. Certified professionals handle the complex maintenance and testing, and you, the user, the homeowner, stay informed, inspect regularly, practice mentally, and act responsibly. You are the final, crucial link in that chain of safety. Outro. Wow, we've journeyed deep through NFPA 10, from its fascinating historical roots over a century ago to the granular details of fire classification, agent selection, precise installation rules, rigorous maintenance schedules, and critical testing procedures. What an incredible deep dive into these silent sentinels of fire safety.
It truly highlights that a portable fire extinguisher is so much more than just, a red can on the wall. It's a precisely engineered, carefully selected, diligently maintained piece of life safety equipment. It's absolutely vital in those critical initial moments of a fire, but only if it's the right type, in the right place, properly understood, and fully ready for action.
Absolutely. You've now seen the layers of expertise and the detailed journey from its conception in standards committees to its ongoing maintenance in your workplace or home, all designed to give you that crucial split second, that fighting chance when a small fire could potentially become something much, much bigger. We've learned about the absolute mandates of shall versus the strong recommendations of should, the critical difference between those quick monthly visual inspections anyone can do, and the thorough annual professional maintenance. And that surprisingly long and important list of obsolete extinguishers that you might still encounter, some of which are genuinely hazardous.
And let's not forget the crucial takeaways for home users. From Annex F, from those minimum ABC ratings recommended for each floor, to the warning against using dry chemical on your expensive electronics, and those very specific, potentially life-saving rules for kitchen fires, especially that advice for commercial kitchens to actuate any fixed suppression system before grabbing the portable extinguisher.
So after this journey, what does that red cylinder on the wall represent to you now? Hopefully it's no longer just a red can. It's a testament to rigorous science, constant evolution based on experience, and a shared commitment to safety involving manufacturers, standards bodies, service technicians, and ultimately you.
Yeah.
You've now gained, hopefully, an appreciation for the intricate design, the continuous oversight required, and the critical decisions that go into giving you that moment of protection. You'll know to check those labels, maybe glance at the inspection tag date, confirm it's not on that obsolete list, and understand that its readiness is truly a shared responsibility.
It really is. And it raises, I think, an important closing thought, or maybe a question for everyone listening. In a world that seems full of potential hazards, both big and small, is simply owning safety equipment like a fire extinguisher ever really enough? Or does true protection, true preparedness, come from consistently understanding it, actively maintaining it, and knowing how, and importantly when, to safely deploy it when it matters most?
That's a powerful thought to mull over. Is passive ownership enough, or is active readiness the key? Thank you for joining us on this deep dive into portable fire extinguishers and NFPA 10. We hope you feel much more informed and empowered about this essential aspect of safety in your daily lives. Until next time, stay curious and stay safe.